Very pretty though.
Like a rainy weather, I feel it's not too much heat as well as it's not too
Mm-hmm.
cold. It's that pleasant, comfortable weather. I really
Nice.
like
I
rainy
do love
weather.
the rain. Mm-hmm. I think it's very relaxing. Yep, it looks like we're live on Twitter and YouTube, so we can get started whenever. Um,
Okay.
I have a quick comment here. Mm, I'm not sure. Candy mentions that your audio is a bit quiet, so I'm not sure if you can get closer to your mic. Maybe if that's an option. I did
Is it
adjust your user volume, and
is it
it's
better
good for
now?
me. Oh, I think so. Hmm.
I'm just changing the sensitivity of the mic so that it's appropriate.
Nice. That's better for me.
Okay.
Amazing. Oh,
Maybe
yeah, it
Candy can
looks like.
confirm it once.
Mhm. Let's check. I've sent her a message. But while we get that confirmation, hello everyone. Welcome to today's Dev Deep Dives. We have Geeta on stage today, which I'm very, very excited about. And he will be talking about blockchain intents, an intro in blockchain intents, how AI is shaping the future of Web3. I think this is going to be a very interesting one. And I also wanted to know that we have a bow up for today's session ready to go. So we will likely distribute it by the end of the call. So be ready for that. I'll let you guys know once that it's available to be claimed. But having said that, I think that we're good to get started. So I'll pass it on to you, Gita.
Okay. Thanks, Phoebe. So, hello, GM. So this is a dev deep dive, which is a continuation of the previous one hosted by Raymond, where he introduced how we are working on the Teleference AI and the machine or the engineering behind it. Today, I wanted to talk about a niche topic, and I feel it's more of an introduction chapter to how actually AI systems work and how it enhances the Web3 ecosystem usability. This is called blockchain intents, and this is how the AI actually understands what you're saying or what you're speaking to the AI, and then it executes trades on your behalf, or it's a trader which can understand natural language. Okay, so moving on. The first thing in today's agenda is the introduction to intents in blockchain. And this is where I introduce what is the word intent and what is a formal definition. And this entire presentation today will be a very beginner presentation. We will get into some of the roots of the technology, but we'll all over the next 10-15 minutes we'll understand it from a higher level, so that at least the viewers can get a bit excited on what this technology is, and they can also dive deep on their own and read up on their own. So this is more of an introduction chapter. Then the second point which we'll discuss is the entire flow of how a blockchain intent system works. So starting from your prompt to the execution, how does it work? Next, we'll discuss something called intent resolvers and how do we implement that. So, intent resolvers are basically the systems which take your input or your chat message and then it converts it into a transaction. So, how does it happen? After that, we'll dive a bit deep into AI models. So, I am pretty sure everyone has heard about AI and AI models, but often we try to understand what these AI models mean. Like, what are they actually? And this blockchain intents, these systems use basically two types of AI models. One is the classifiers, and then the named entity recognition models. I'll go and explain all this in detail, but I'm just giving an overview of the agenda. After that, once you get all the intent resolved and you know what transaction we have to do, Then I'll explain how we do it in the Collabland runtime, how we execute that intent into transactions, and then I'll conclude the presentation. Okay. So the first topic is what is intent in blockchain. So an intent in blockchain represents a specific objective a user wants to accomplish on chain. And the user simply states what they want to achieve in plain natural language. Something like, I want to swap one USDC to ETH on Arbitrum, or I want to buy one USDC from ETH on Arbitrum. That's the simple language, as if they're talking to their friends. And the recipient system has to somehow figure out how it can achieve that goal. Now, the achieving of that goal can be in one step, can be in multiple steps. That is the job of the recipient system, and that is the job of the telefriends AI in our current initiative. The steps which the solver, so we call these solvers or solving systems or the intent resolvers, the steps which the solver or the system solving for that intent takes might use technologies like AI, smart account infrastructure, different exchange APIs like centralized or decentralized exchanges, etc. As mentioned in the last Dev Deep Dive, Collabland is working on integrating blockchain intents into Telefriends. So this is an overview of the entire blockchain intent flow. So we have mainly four players while we are dealing with blockchain intents. One is the blockchain specific transactions or the APIs like centralized or decentralized exchange. Then there is an AI agent, and then there is the Telefriends backend, or our backend infrastructure or the runtime which processes all these requests. And then there's you, the user, who's talking to the Telefriends bot and then executing the trades using natural language or simple English language. So the flow goes like this: the user says, "Okay, I want to swap 10 USDC to ETH." Then it says this to the Telefriends bot. Now the Telefriends bot then asks the AI agent, which is behind our runtime, which is integrated into our runtime, and it tells the AI agent, "Okay, what is this user saying?" And then the AI agent tries to figure this out. Now it tries to figure this out in broadly two steps. One is it tries to understand the base intent, which means what is the higher level understanding. So if I take a sentence, what is the base understanding? So if I want to tell, okay, I want to buy 10 apples, what is the base intent? The base intent here is buying something. So it's a buy transaction, if I would say. So the first step is to actually understand the base intent. Now, once you've understood the base intent, then what you do is try to extract the parameters, the transaction parameters. So, taking the example of buying apples, now you can understand in the sentence, I want to buy 10 apples, there's actually two parameters. The base intent is buy, then the two parameters is one is 10 and second is apples. So the type of fruit is apples and the amount of fruits you want to buy is 10. So that is how from the base intent, after understanding that it's a buy transaction, you're extracting the parameters from that sentence. You're extracting these words from the sentences. And once it gets the transaction parameters, it sends to our backend. Now, once the backend has gotten the transaction parameters, as well as at this point, it also knows the base intent, which is basically the buy transaction. Now, what it does is it calls different, if required, again, if required, it will call different decentralized exchanges or centralized exchanges APIs to get the contract addresses for the different smart contracts which help in bridging, swapping, etc., etc. So one of the partners which we use is like Lefi. Lefi helps us to do this, and they have provided their APIs to actually help us, create these bridging transactions or swapping transactions. And once we get back the contract addresses and parameters from these, third-party APIs or partner APIs, then the backend, the Collabland runtime creates a series of user operations. And I think Raymond has talked a lot about ERC 4337 and how smart contracts and user operations work in the Collabland runtime. So what we do is, after getting these parameters, what we do and getting all the contract addresses from these different third-party APIs or partner APIs, we now create the series of user operations which has to be executed against your smart account, because you are using a smart account to automatically trade, right? It's easy for the Teleference AI agent or the Teleference runtime to execute on your behalf through ERC 4337. And then what we do, once we have created all the transaction objects, or the user operations, we submit these user operations, and hence we execute the transactions on your behalf. And that is how the we send it to the blockchain. The blockchain executes it and submits it, verifies it, confirms it, and then we send back the receipt to the user, and hence the user has basically done trading using simple natural language, or what in short we can call is AI trading, right? So how do we actually implement these intent resolvers? How do we actually implement this entire, complicated system which you see here? What are the broad, steps or ladders to overcome? So it all starts with the user input, as we have understood. So we can type something like, slash intent. I want to buy 10 USDC from ETH on Arbitrum. That is a user input. It's a slash command for a teleference bot, maybe. Then it goes through a classifier model. Once the model is classified for the base intent, as I was mentioning, once the model is classified for the base intent, then that classification context is then sent with the input to the NER, or the named entity recognition model. I will definitely get more deep into this, and I'll explain how this NER model works. But this NER model is basically responsible for extracting the parameters. So these NER models, what they do the parameter extraction. They take the user input, they have the classifier context, and then they extract parameters from that. After that, they build something called an abstract transaction object builder. So an ATO, or an abstract transaction object, very in simply, like if I explain like explain like I am five, it's basically a JSON object which tells what type of action it is and what are the parameters to that action. And that basically then sends that is like a, I would say, a knowledge, or that is like an understandable format for the Collabler runtime to understand. So the Collabland runtime cannot understand a natural language, but they can understand a JSON object with very specific parameters, as if someone is calling an API on our runtime. So once we get this ATO, or the abstract transaction object, that is passed to the transaction builder. This is where we call different third-party APIs, different partner APIs, and we collaborate with them. We call their APIs, we get their data, and we create these different user operations. Series of user operations. So if it requires multiple swaps, or if it cannot be done through one contract, so you need a series of user operations, and all that user operations is then bundled and created, and then these user operation builders submit the transactions, the smart account transactions, and that gets executed on the blockchain. Once it's done, we definitely, since you're building an AI system, and when I feel for all AI systems, there has to be a consistent user feedback system. So when you've used ChatGPT, I'm sure you've seen ChatGPT continuously asks for user feedback. Like, okay, did I write this correct or not? This is because AI requires feedback for something called reinforcement learning. So basically, on the feedback which you're giving the AI, okay, this is a correct prompt. No, this is a wrong prompt. This AI then takes this data, this feedback data, and then it trains itself, or it tells itself, okay, these are the correct inputs. So these pattern recognition which I've done is correct. So do remember this for future inputs. And that is how the AI progressively improves itself. So this is the entire loop, I would say, for intent resolvers. And now, talking a lot about AI. So what is AI models? So I generated this coincidentally. I generated this through Gemini AI, and it is a very good explanation of what an AI model is. So Google Gemini says an AI model is like a smart robot that learns things by looking at examples, just like people do. So when you show an AI a red circle and a blue square, it will first learn which color each one is. And when you show it many examples, it will start to recognize patterns and make predictions. So this is how it's mostly like a pattern recognition model. So this is something we as humans we also did in our childhood, right? When we started going to preschool, what did we do? We were given these red pictures of red apples and yellow mangoes, and this is how we used to understand. Oh, okay, so if it's red and it has a shape of an apple, that means it's an apple. And if it's yellow and it has a shape of a mango, so even our brains somehow do the same procedure, and they are also an expert at understanding shapes, colors recognition, and that is how this entire AI models also work. So for example, if you show an AI model many pictures of cats, it will eventually start to recognize cats in these pictures, and that is basically how even classifiers work. So the two main types of models most blockchain intent solvers will deal with are classifiers and NER models, which is named entity recognition models. So let's try to dive deep into these two models now. Now it will get a bit more technical, but then again, I've tried my best to simplify it. So classifiers are AI models, but I like to call them the vibe checkers because I feel the best way to explain classifiers is your best friend checking your vibe every 10 seconds or every 5 seconds or every sentence you say to them. So, what it does is it's an AI model specifically trained to classify natural language prompts into broad categories ranging from suppose swap, bridge, buying NFTs, or even staking. So you can see here there's two users, Alice and then Bob. Although Bob is the classifier, he's also called the vibe checker because if Alice says anything to Bob, Bob just replies with the vibe he feels about Alice. So whatever Alice is saying. So if Alice wants to say, I want to buy 10 USDC from ETH on Arbitrum, Bob instantly replies by saying, okay, it's giving swap vibes. So the base intent or the base vibe of that certain AI prompt is swap. It just replies with single word labels. And if suppose Alice tries to say, okay, I want to send one ETH from Optimism to Arbitrum, so Bob thinks, okay, what this might mean. So it tries to analyze from its past experience, and then it says, okay, Alice, I think your vibe it's giving bridge, and basically tells that okay, this is the base intent is bridging transaction. It is a bridging transaction which you're trying to do. So once you get the base intent, then you can pass it to the parameter extraction model. Now, one thing about AI, which is very important, and I think it's the most important in understanding how these models work. So here, what you're seeing is an output of the model, right? But what is the input to the model? What type of data does the model consume to actually recognize these patterns? So next we talk about the data these models train on, or the data it consumes and learns the patterns to eventually spit out the output when you give some input to it. So here you can see this is a very sample data set which we usually feed into a classifier for training that model or for teaching that model how to recognize intents. It is mostly like an array of objects, and there's basically two things in this object. One is the type, which again, as we were mentioning, is the base intent, and second is the statement. So you can see this is a sample statement. Please facilitate the swap of my 50th for the maximum number of USDC token, and this is labeled as swap. So this is a pre-labeled, or this is like a known data set, and you feed statements like this in in magnitude of thousands to this AI, and then after analyzing and understanding the patterns, so if it sees any similar statements to this statement, it will immediately recognize it as a swap intent. And if it sees something like I want to buy a BAYC available on OpenSea that can be purchased under 10 ETH, if it sees a statement like this from a user, it will automatically classify it as a NFT buying transaction. So this is the type of data these AI models are feeding on to actually understand the inputs at a later stage once the model is trained. And as you might have known, or it's like a very common thing which people know, that is, the more the data you feed into the AI, the smarter it becomes. So that is actually one of the problems in AI development as well. Like always, sometimes you don't have a lot of sample data to feed to the AI or to train the AI, and we have to then wait or create a lot of custom prompts and think about different sentences and the vocabulary, and then create these data sets. Sometimes, okay. So I think this explains mostly how classifiers work. I won't go into how the model itself works, but this is like mostly a overview of how classifier models work. Now that it has classified, now the second thing is parameter extraction. Now, what is the word parameter extraction mean? So parameter extraction is actually a procedure of extracting the transaction parameters from the natural language. So this graphic actually exactly portrays what it means to. So if you see, the input to the parameter extraction model is basically the prompt, and then it resolves to this JSON document, which I was actually talking about, right? So this JSON document converts the sentence into a machine readable format, is what I would like to call it. So this is something the Collabland runtime can understand easily, right? Because see, you can see it has the action, it has the source token, it has the destination token, as well as the chain and the amount of token to be swapped. So it has everything in a digestible format which the Collabland runtime can then understand. And how do we achieve it? We actually achieve it through a model called named entity recognition. So, what is a NER or a named entity recognition model? It is an AI model which is specifically trained to extract entities from a natural language prompt and then returning to the user. So, here we again come back to Alice and Bob. This time, Bob is not the classifier. This time, Bob is an NER model. I should have named it Charlie, but it's okay. Let's go with Bob. Bob is multitasker. So Alice had given Bob two inputs, right? And one was I want to buy 10 ETH, 10 USDC from ETH on Arbitrum. And the classifier context had given a vibe or a classification of a swap transaction. So taking this context in as well as the natural language which Alice has given, combining these two objects or these two contexts, it then returns something like this, which we saw in the previous slide. It returns these named uh, entity recognition. So it pulls out these words. If I would simplify it a bit, it pulls out these words from the sentence and then tries to label it as its own known labels. Like if it knows something like, okay, I have to label. So if it's a swap transaction, I have to somehow find out a source token. I have to find out a destination token. I have to find out a destination amount as well as some chain. And I have to find out all these four properties from the sentence or the input or the prompt which Alice has given. And then through its previous learnings, which again I'll discuss in the next slide, through its previous learnings, Bob somehow tries to fish out these words, exact to exact words from the sentence. So now you can see Bob has actually found out all the four properties. So it says to Alice, okay, the source token is ETH, which is this ETH. The destination token is USDC, which is again available on the prompt itself. The destination amount is 10, which is again available on the prompt. And the chain is Arbitrum. Ignore this. This is something I wrote for extra context, but the chain is Arbitrum, which is also available on the prompt itself. If it actually fails to find out at a later stage, obviously, advanced AI, if it fails to find out a parameter within the sentence, it should actually ask follow up questions. So if it suppose has not find out the chain, Alice forgot to mention the chain, suppose, then it should again ask Alice, okay, what is the chain? Because it's the only parameter it could not find out. And this is how you can see with the context from the classifier and the input from Alice, you parameterize the entire prompt into these digestible amounts or these digestible data, which the collaborator and runtime can then understand. Now, in order to do such parameter extraction, it's a curious thing that how do they actually train, or how, what kind of data do you actually feed into this AI model to actually teach that AI model, okay, this is how you label stuff, and this is how you are supposed to, extract or fish out words from the prompt and then give them a certain label. So let's see a very sample data set, or a sample input data, if I would say, input data set when you're training the NER model. So here you can see a sample data set. It mostly contains a set of labels defined as per the natural language prompts and the words defining these labels. So now you can see there are two data elements inside this data set, right? So the first element has a text, which is the natural language. So it says Apple is expected to release the new iPhone next month. Now you can see the named entities, the array of named entities. Inside the array of named entities, you can actually see how the labeling is done. So you can see starting from the 0th index to the 5th index, which is this word. So starting, because obviously when you're feeding data into the AI model, you have to tell where the word is right in the sentence, right? So it tells the index in the sentence. So it tells that this word Apple refers to an organization. And then you can see it also feeds one more data, because there's two entities in this sentence. It also feeds one more entity, which is from 36 to 42th index, character index, which is this iPhone. It should be labeled as a product if someone asks in a sentence like this. So basically, it gives the AI natural language input. It tells, okay, from this index to this index, which basically is like a substring which it collects from the above sentence, and then it assigns a label. And now, when you feed huge amounts of these labeled data to the model eventually understands the pattern of how it has to label something as a organization or a product or a person or a location, because it starts to derive these patterns from the input data. Now executing the intent. So now we have finished the classification, we have finished the parameter extraction. Now once we have got the ATO, or the abstract transaction object, now we have to execute an intent, execute it right on the blockchain. That's the ultimate goal, to understand the simple sentence of the user and then execute it. And as I mentioned, sometimes the instruction which the user is giving, that isn't a single step instruction. So suppose if the user gives an instruction of swapping 10 USDC to ETH on Arbitrum, that is easy, right? But if the user gives an instruction of buying USDC on Arbitrum through their funds on Optimism, then what we have to do, we have to first bridge some ETH from Optimism to Arbitrum and then swap it on Arbitrum. So in that case, the intent solver has to create these set of instructions, and that is where actually these user operations are really helpful. So now that you have gotten the base intent and the context and the ATO, if I would call it that, then it is broken down. Now it is broken down into these steps. And for each step, if there's like additional parameters required for the transaction, then we call these different blockchain APIs, as I mentioned, like we already use LeFi, Paraswap, as well as OKX. We take these different blockchain APIs and we try to merge all the data from their APIs, which mostly contains like the contract addresses and everything, and we create the transaction call data, and we create a series of user operations which has to be executed. And once the transaction objects are created, the Collabland, a smart account infrastructure or account abstraction infrastructure, uses the smart contracts to execute the intent of users and then send back the transaction receipt as well as acquire feedback from them, so that we always get that continuous feedback cycle. And this is how, from a simple sentence, a blockchain transaction can be executed. So there's definitely much more into blockchain intents that what has been covered here. I hope this presentation was mostly a head start into how AI and blockchain can create beautiful applications and enhance the user experience of Web3, as well as I hope it sparks a curiosity in all of you to actually go and study a bit more about AI. Now that I've broken down AI into simple chunks, so I personally feel that showing what type of data the AI trains on really helps on understanding how it does all this magic. Because at the end of the day, for many of users, even for myself, when we were working on this, I am very new to AI, as you might have noticed. If there's any advanced AI, researcher here, for me, understanding the different data formats and the input data and what data AI ingests to actually do this classification or do this parameter extraction, it actually helped me a lot, and that's why I wanted to show the input data of how it is working. So I hope it has sparked a lot of interest in all of you to go ahead and dive deep into AI. Definitely, AI is going to be, I won't say it's going to take over everyone's jobs, but it's going to be a major part of our lifestyle moving on. So here at Collabland, we are also gearing towards the release of this AI feature on Teleference soon. While we figure out the technology and research into the enhancement of this feature, we definitely appreciate any feedback you might have in the process, and always open to suggestions, enhancements, clarifications. While we're building it, I think Collabland, us at Collabland, we are big supporters of building in public. So shoot us a tweet on X, or DM us any doubts. We are here to solve. So thank you. Keep exploring, keep building. As I mentioned, this is our Twitter handle. You can go there, or X handle. You can follow us. Do follow us for more updates. Shoot us a tweet. Any doubts, we are always here to answer. That's all from my side. Thank you so much. Over to you,
Thank
Shivi.
you, Gita. It's a shame that we don't have soundboard in the stage. It should totally be a thing. But since we're not, I'll just go ahead and clap, 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 clap for you. Thank you, Gita. This was a very fun presentation. Um, I want to ask you something, and also everyone in the audience, because I'm curious. And I think that this has came from some discussions from the team internally. But would you, Gita, and would everyone in the audience trust AI to trade for you? And I have another question when it comes to like the requirement fields that you can incorporate in order to use the intents. Like, would you, for example, be able to tell the I want you to, I don't know, I want to trade certain amount of whatever token, but only with a maximum of, I don't know, a $1 cap for gas? Like, would you be able to specify all of your requirements like all that well, like how much you want to be spent on gas, or I don't know, any other requirements that you have? Is that a possibility?
So that's definitely a possibility, and the ultimate goal, what we are trying to achieve, and definitely through different variations, is this helper or this agent which is helping you gain profit. So there's these terms in trading which is called stop loss and take profit. So stop loss is, from what I understand, is when you've bought some token and you mention this AI that okay, if this token goes below this price, before when it goes below this price, try to sell the tokens to not incur further loss. And take profit is if you want to mention, suppose this percentage of profit you want to gain from this token, if it's a token which is getting pumped, right? And the AI can
Mhm.
automatically do these transactions for you. And
Mhm.
the AI can set these parameters. So all of this is how gradually we develop the AI and how advanced it can become. And
Mhm.
the first step is to get a very basic version loaded out so that we can uh, you know test. And as you saw, we need a lot more data, right? So
Yeah.
we kind of expect or rely on our user base to also give us some feedback, and that is how we can increase the capability of the AI features which we'll roll out. And personally, for
Mhm.
me, I would say I'm a very optimistic person about technology, so I would definitely allocate at least 10% of my portfolio so that I can trade on AI, because I feel
Nice.
if we do not help the technology to improve, then we cannot expect the technology to just improve on its own, especially a data driven technology like AI. So everyone should contribute to the development of it. I feel
Mhm.
that's my personal opinion.
Yeah, that's a good take. I Yeah, I think I can relate to that as well. And as long as you can pick your parameters and just be specific on what you want to achieve, I feel like it's super easy if AI can do it for you. So I'm all for that, really.
And
I
it's
do see
just
some
like
people. Yeah, go ahead.
and it's just like a baby, right? Like first it will do very simple tasks, so there's no complicated or there's no huge loss incurring transactions it can do. But eventually,
Hmm.
when the users, you're teaching the AI through feedback, then the AI starts to
Hmm.
learn more and more complicated transactions. So it's basically everyone is teaching this child to do several steps or several dance steps or something like that. So everyone's contributing to the development.
Hmm. Totally. And I think that's very cool. So I am looking forward to giving it a try and also learn some more on how this will all be implemented to tell friends because that's coming, isn't
Yeah, it's coming very soon.
it? We'll keep you guys posted, as always. Before we get to the PO-up, I wanted to mention if anyone has any questions, please feel free to either type it in the state chat or you can raise your hand. We've enabled that option too if you'd like to come up to the stage to ask your questions or make any comments. Please feel free to. But now, I think that it's a great time to distribute the bow up. So let's get to that. And oh, I noticed, and Candy sent me a screenshot. Um, we have a big audience on Twitter. So for everyone watching on Twitter and or YouTube, if you'd like to claim the PO-up that we have for today's session, you need to hop on to our Discord server. So you can go to your browser, type down discord.gg/collabland, and you'll be able to join our server. This is because we are using the PO-up mini app. So that's all done inside of Discord. So you need to come in here, type it in any of the channels, and you'll be able to claim your PO-up. But now, for everyone in the audience, to claim the PO-up, you need to type down /PO-up claim. Oh, or if you're in the state chat, you can click the command that I Speak Nerd sent. You'll see that it's highlighted in blue. You click that down, and that will ask you for a claim phrase. Now, today's claim phrase is vibe check. And this is inspired in the vibe checker. I totally love that. And kudos to Gita for the inspiration for this claim phrase.
Yeah,
Now
it's
it's
a good analogy.
yeah, I love that. We changed it a little bit, and I'm sorry if it's difficult, but let's repeat it one more time. It's all lowercase and with no spaces. Again, the claim phrase is vibe check. Vibe check. So VIBECHECK. Vibe check. Again, all lowercase with no spaces in between or anywhere. Please give it a try. Let us know if you were able to claim successfully. If you have any issues with claiming, make sure to reach out because we can get you a code for you to claim the POAP. No worries about that. You can tag me in the general chat or anywhere and I'll get you a code. But one more time, in case you missed it, slash POAP claim in the chat, and the claim phrase is vibe check with no spaces in between. Do you get yours, Kita?
Yeah, it looks beautiful.
Oh, thank you. It's inspired on today's topic. Kudos to you as well for that.
If you have become an expert at designing POAPs right now, I feel.
Yay. It's been quite the journey for sure. Oh, I just recently reached my 100 created POAPs mark. I think I must be in like 105 now or
Congratulations.
something. Thank you. Yeah, it's been quite the journey. And we've taken feedback from people actually. And I think that's helped us improve a lot when it comes to our POAP designing. So always feel free to share your comments and feedback. Let us know what you think. Also, ideas are appreciated as well. So really anything, do let us know. We appreciate that. But all right. I'm not saying any questions right now, but you guys, if I don't know if anyone's listening to this recording in the future and you happen to have any questions, make sure to reach out to us. You can leave it in the general chat of our Discord server or shoot us DM to our Twitter. Anything works really. But yeah, having said that, I think that we are ready to wrap things up. And thank you again, Gita. Really, really happy and excited to have you here. And thank you for your presentation. It was fantastic.
Thank
Kudos
you,
to
Chief.
Gita. Yay, I hope
Thank
to
you,
have you again in
everyone.
the future.
Yeah.
You are
Thank you,
invited
everyone.
here anytime.
Yeah, sure.
Thanks everyone for attending. We'll see you guys tomorrow for our Collab Community Twitter Spaces. Tomorrow is at 3 p.m. Eastern. So I do need to edit this. And I'll share with you guys the Discord event so that you can hit that interested button if you would like to attend. And we'll be talking about security. I have some things to share. Like, yeah, attend tomorrow. I'm eager to talk about security. But you guys, let me share. Oh, we have the Spaces link already. Amazing. Okay, I'll add the Spaces link to the Discord event, but you can hit the interested button and you'll be notified when the event is getting started. Also, if you'd like to speak, to join as a speaker, please feel free to. You can reach out to us and let us know if you'd like to join. Or on the day of the event, you can just join and request to be a speaker, and we'd very, very gladly have you join us. So I hope to see you guys in there. See you all tomorrow. Have a wonderful rest of your days. Bye bye.